look at using the conjugate pairs theorem. And to start this whole discussion, we're first going to go back to something with which we're pretty familiar, and that is just finding roots of a really simple quadratic equation. So if I'm going to find the roots, and now remember, the roots mean that they have taken out the y and replaced it with a 0, which means it used to be just a function, quadratic function, and now they're asking for the x-intercepts of that, right? Make a y a 0, and now they want the x-intercepts. So we're going to factor it, which is the easiest way to find this. And then if you remember, what we do is we set each factor equal to 0. And we get that x is -2, and we get that x is -1. Now, again, what have we found? We found the x-intercepts. Okay? The x-intercepts of the function, right? If I put the y back in there. Okay? So we found the roots, or the zeros of the equation. So, what if I just covered up this right here? Let's pretend like we didn't see it, and I asked you to come up with a polynomial, and all I gave you were the roots. Well, of course, you would say, okay, well, let's go backwards. You would go plus 2, and you would say x plus 2 is one of the factors, plus 1, and you'd say x plus 1 is the other factor. You would multiply them back together, and you would get the polynomial that had those roots. Okay? All right, or the x-intercepts. Okay, so let's continue this whole idea. Let's go ahead with this next question. We're going to find the roots of this. All right, well, I guess the best way to do this is just to get the 2 on the other side, and we're going to go x squared is equal to -2. And you can already see that there's going to be a problem here in terms of real roots. But it just said find the roots. So here we are. We have x is what? Well, this is the same as the square root of -1 times the square root of 2. And we know that this is the letter I. Now, when we take the square root, of course, we put the plus or minus. Excuse me. All right, so we have the plus or minus the square root of 2i. All right? Now, that's 2 roots. Now, if I take a quick little picture, they're imaginary, right? If I take a quick little picture and I draw this graph, this is a parabola. Again, we're going to put this back into, we're going to put it back with a y in it, and we're going to graph the related function. So we're going to go through the 2 up here, and it's going to be like this. Now, does it make sense that there are no x-intercepts? Sure. We just found that they were imaginary. And so that makes complete sense that we shouldn't find any real ones. We should find 2 imaginary ones. Now, the reason I brought that up is this. Imaginary roots always come in groups of 2, in pairs. Imaginary roots always show up in pairs. So we call those pairs conjugate pairs. Now, let's take a look. Here's what we mean by that. Let's just say I have 3 plus 2i. Well, the conjugate would be 3 minus 2i. Okay, so what if I had -3 minus 3i? Well, the conjugate, don't change the first one. We change the middle sign only. That's what a conjugate is. We only change the middle sign. So those are conjugate pairs. All right? And they always come in a pair, right? It's implied. It basically says it right there. It comes in 2. They come 2 at a time. So let's now take a look at putting this all together. It says to find a polynomial equation with real coefficients, and that just means that if I had 3x squared plus 2x minus 5, right? There's the polynomial equation. That these right here are real. Those are the real coefficients, right? In other words, don't have any imaginary ones in there. Well, that's what we're working with, so it's going to automatically be real coefficients. All right, we have a 3 as a root, so x is 3, and we have 1 plus I is another root. Now, what we just talked about is that imaginary roots come in pairs of 2, always. They come in pairs. So then the other one would have to be, that they didn't give us, would have to be 1 minus I. Okay, so we're going to call this one implied. In other words, they don't have to tell us. We know that it has to be another root. They come in pairs. Okay, so let's take a look. Let's go right back up here to where we did this first problem. Okay, what in the world? Okay, I guess I missed one. Let's go right back up here and see what we did to go backwards. We have a -2 and a -1. What did we do? Excuse me, let me go back here. We basically started with getting the everything on one side, right? We got everything on one side equal to 0. In other words, right here we've got this equal to 0 and we've got that equal to 0. Okay, and then we're going to go ahead and go backwards from that, and we're going to go ahead and multiply them together. Okay, and so technically this would be 0 initially, and then to go ahead and pull the 0 out, we would end up with our polynomial, which is that. And if we wanted to, we could go ahead and write, hey, that's a function. Okay, so what did we do? Let's take a look. We basically got everything on one side. Okay, from the x equals. We got everything on one side from the x equals. We're going to do that here. Alright, we're going to get everything on one side from the x equals. So -3, -3. Here's what we get. We get x minus 3 is equal to 0. Terrific. Guess what? X minus 3 is one of my factors. Okay? Now, this is kind of weird, but we're still going to get everything on one side. Okay? I'm going to go -1 minus I. -1 minus I. Because I want everything on one side. Now, it just so happens I have the x on the right, but it's no big deal. So I've got 0 is equal to x minus 1 minus I. Okay, do the same thing to the other one that was implied, in other words, that we just knew had to be there. -1 plus I, right? -1 and then plus I. I could do it in 2 steps, but I'm just going to go ahead and get it done. So we have 0 is equal to x minus 1 plus I. Now, that means that this is a factor. So here we go. I'm going to go ahead and write x minus 1 minus I. And I'm going to go ahead and write this one, x minus 1 plus I. And we are going to multiply all of these together, and we will get a polynomial equation with real coefficients that has these roots. Okay? Now, let me give you a little hint. Always multiply your conjugate pairs, your imaginary pairs together. Always multiply them first. Here we go. We're going to do a fancy form of FOIL. That's all we're doing. X squared. We're just going to spend a little bit extra time on the FOIL. We're going to have it go 3 times. Plus xi. Here we go with the next one. Minus 1x. Plus 1. Minus 1i. And the last one, minus xi plus 1i and minus I squared. Now you're already going, hey, wait, I recognize I squared is something else. Well, we're going to take a look at that. I'm going to double check my work real quick like. Looks okay to me, so let's get it consolidated here. There's that. I have a plus xi and a minus xi. Those are going to add to 0. I have a minus 1x and a minus 1x is going to give me a 2x, minus 2x. So I've got those. I have a minus 1i and a plus 1i. Those are going to add to 0. Now, let's take a look at this. We know that I squared is the very same thing as -1. We know that from algebra, right? Algebra 2, and maybe even algebra 1. So I squared is the same as -1. So if I have a minus a -1, then that's going to turn that whole thing into plus 1 right there. So then I have a plus 1 and a plus 1, which is going to be plus 2. All right, ready to finish this up. Just going to multiply these together and I'll have my polynomial. X cubed minus 2x squared plus 2x minus 3x squared plus 6x minus 6. Let me see if I did that right. Plus 6x minus 6. Alright, let's see if we can get it consolidated here. We've got that. I've got minus 5x squared. I've got plus 8x, and I have minus 6. And that, folks, is my polynomial. And the roots are 3, and then 1 plus I and 1 minus I. So, if I were to graph that, we would know that the end behavior does this. It has one real root going through at the 3, and then the other two are just imaginary. Okay? Let's take a look at one more. Find a polynomial equation with real coefficients that has 3 and 2 minus I as roots. That's weird. Let's go ahead and put as roots. Alright. So, this is x equals 3, so then it becomes this as a factor. Okay? So, x equals 2 minus I. We know, though, that the implied one is that, or the understood one is that, because they're conjugates, conjugate pairs. So now, let's go ahead and get everything on one side, minus 2, and then plus I, minus 2 and plus I. So I have x minus 2 plus I is equal to 0. Once it's equal to 0, that's my factor. Now, if you're not sure why, how do I remember that's the factor? Go back right up to here. Right? As soon as I got the x's on one side, x and the numbers on one side, it basically kind of jogs your memory, right? And we realize, oh yeah, those were factors. Okay. So we're connecting it to something with which we're familiar. Minus 2 minus I. So x minus 2 minus I equals 0. Alright, so here's the other factor. Okie-doke. Let's take a look. X squared, I'm doing these first, right? Minus 2x. We know it's going to end in negative I squared, right? Okay, so there's that, and in a minute we're going to multiply through again by that. So we have x squared minus 4x. Let's see, what do we have here? We have that, goes away with that. You notice the i's are going away. If the i's don't go away, we have a problem. We really do have a problem. So minus a negative there is going to be plus, so we're going to get a plus 5. Alright, so now let's multiply that, and we're just about finished. Oops, do you see that? I noticed there was not another x squared. Oh. Okay, so x cubed minus 4x squared plus 5x. I'm just double checking my work because I just noticed, hey, wait a minute, I didn't get another squared in there, and I know there's supposed to be another squared. Okay, so we have negative 7x squared, negative 4, negative 3, and I have 17x minus 15. And that is my polynomial. If I graph it in the calculator, I'm going to see one real one at 3, and I'm going to see the rest of them as imaginary. Alright, thanks for watching.